Now let us take another example, and which is we are given a function f x square y minus 2xy square plus 3xy plus 4, and we need to find points of local maxima, local minima and saddle points. So first we'll find critical points, and for that we'll find its partial derivatives. So del f upon del x, which we also write as fx, and it'll be 2xy minus 2y square plus 3y equals 0. So we'll take y common and we'll get 2x minus 2y plus 3 equals 0. So from this first condition, we'll get either y equals 0 or x minus y equals minus 3 by 2. Now we'll differentiate partially with respect to y. We'll find fy, and it'll be x square minus 4xy plus 3x equals 0. We'll take x common. So it'll be x minus 4y plus 3 equals 0. So we'll get the condition either x is 0 or x minus 4y is equal to minus 3. So now we have 4 conditions. Either y is 0 or x minus y is minus 3 by 2, and x is 0 or x minus 4y is equal to minus 3. So we'll get 4 points. So the first point will be when y is 0 and x is 0. So one of the point is 0, 0. Second critical point is when y is 0, and if we'll put y as 0, we'll get x as minus 3. So the other point will be minus 3 comma 0. Third point is when x is 0, if we'll put x as 0, we'll get y as 3 by 2. And fourth point we'll get from the intersection of these two lines. So we'll subtract second line from first. We'll get minus y plus 4y, and it'll be minus 3 by 2 plus 3. So we'll get 3y equals 3 by 2. Value of y is 1 by 2. And if the value of y is 1 by 2, value of x is minus 1. So the fourth point will be minus 1 comma 1 by 2. So we have 4 critical points where we need to examine whether they are points of minima, maxima or saddle points. And for that we'll need to use second derivative test. So we'll find a, and that is fxx. So we'll partially differentiate it again with respect to x. We'll get 2y. We'll find b, which is f yy, and it'll be minus 4x, and we'll find its cross derivative c, which is either fxy or fyx. So we'll find fxy, it'll be 2x minus 4y plus 3. Now we'll begin with this first point, 0, 0. For this first point, a is 0, b is 0, and c is 3. If we'll find h, which is ab minus c square, it is minus 9. And since h is less than 0, 0, 0 is a saddle point. Now we'll take minus 3, 0. So at minus 3, 0, value of a is 0, value of b is 12, value of c, it will be minus 6 plus 3, and there'll be minus 3. Now h again is ab minus c square, which again is minus 9, less than 0. So minus 3, 0 is again a saddle point. Now this third point, which is 0, 3 by 2. Value of a is 3. Value of b is 0. And value of c is plus 1. H here is 0 minus 1. So it is minus 1, again less than 0. So 0, 3/2 is again a saddle point. And finally, we have this fourth point, which is minus 1, 1/2. So for this fourth point, value of x is minus 1 and value of y is 1/2. Now a in this case is 1. Value of b is 4. And value of c is minus 2 plus 3, and which is minus 1. If we'll find h in this case, it will be 4 minus 1 plus 3, and h is greater than 0. So for this fourth point, h is greater than 0 and a is greater than 0. And if h is greater than 0 and a is greater than 0, it's a point of local minima. So we have a local minima at minus 1, 1/2. So out of these 4 critical points, first 3 points, they are saddle points. And this fourth point is actually a point of local minima.